Hi, dear students. I hope you have carefully gone through the previous my video lectures and hope you have understood them properly. What we are discussing? We are discussing module 2. Basically, module 2 deals with the processing of the municipal solid waste. So I told basically there are 3 processing techniques used for the management of municipal solid waste. They are physical processes, chemical processes and biological processes. I also told that sometimes authors also use the word transformation, physical transformation, chemical transformation and biological transformation. Don't get confused with them, one and the same. And we discussed the purpose of the processing, what is meant by physical processes, and in that also we discussed component separation, then mechanical methods, we discussed mechanical methods of volume reduction, mechanical methods of size reduction, and also we discussed various methods of screening, and the last miscellaneous or other types of methods used under specific conditions for separating the various components of the municipal solid waste. I am going to discuss with today. Okay. So as I told, these are some miscellaneous, and we say them as other techniques of component separation depending upon the situation under which you are going through. There are typically 4 methods. One is hand sorting or manual sorting. It is also known as preweaving, and inertial separation, more or less like a density separation, flotation and optical sorting. Yeah. What is hand sorting or preweaving? Preweaving of the waste stream and manual removal of the large sized components of the solid waste is very much necessary prior to other techniques like separation technique, like it could be a size reduction particularly. This is very necessary. Why it is necessary? Many times if certain items like wood items, large metallic items, pillows, rugs, mattresses and some other construction materials, maybe like paint cans, and if they are not eliminated before going for applying some mechanical means of segregation or sorting or separation, there is always a possibility that the equipment may get damaged. So, under most circumstances, in order to remove what I told, it's done to prevent the damage to the equipment, mainly shutters or cranes or any other mechanical equipment that is used for the separation technique. Items are rugs, pillows, mattresses, large metallic components, plastic objects, and then wood and construction materials and paint cans. So, it is always necessary. Okay. However, technologically we are advanced. There will be some situation where we have to go for manual techniques. So, we employ during this process manpower is utilized to pick them and separate, rugs separate, pillows separate, mattresses separate. The main objective of hand sorting, that's why also it is known as pre-weaving, that is weaving very carefully the solid waste material before that is subjected to shredders or screening, okay, or any other mechanical equipment used for the component separation. So, this is all about the hand sorting. Next one is inertial separation. Okay, this inertial method, it relies on gravity separation principles to separate the shredded solids into light organic fraction rather, and heavy inorganic particles. Okay, don't get confused with other techniques of separation. This inertial separation is used after the shredding of the or size reduction of the solid weights, only to just differentiate or separate organic and inorganic. So this separation is very necessary, because these inorganic components or particles need a different kind of handling of the solid waste, whereas organic fraction of the shredded solid waste is handled differently. As I told yesterday, that organic matter can be biological conversion like a compost, maybe aerobic or anaerobic, or it also can be subjected to a combustion process, whereas inorganic atoms are used in a different way. This is inertial separation, and I will show some diagrams here. Yeah, and this is the ballistic inertial separators. Here shredded solid matter enters. Here is a one rotor. All light organic particles are collected here, whereas heavy inorganic particles are coming here. So these are heavy particles and these are organic lighter particles. Two hoppers are there. So the diagram is self-explanatory, and you have to draw this line diagram whenever this kind of a inertial separation is asked in the examination. There is another figure. Yeah, this is also a shredded solid waste. Remember, not general solid waste. Okay, inertial separation is used for this shredded solid waste. This you have. This is the basic difference. So this enters here, and this pulley, it is rotating like this. And when shredded solid waste fall, all the heavier things, heavy and resilient particles are collected here because of the gravity. They fall back, and lighter particles will go up and fall here, and thus collected light and inelastic particles. So these two are the techniques used for inertial separation. This is also known as inclined conveyor separator. Is that clear? Okay. Yeah. Next is flotation technique. So flotation, the simple property of any liquid. Okay. Heavy particles, that is particles having specific gravity more than that of the liquid, water or wastewater. They settle to the bottom, and the particles having specific gravity less than that of water or any liquid for that matter always tries to float. So we are differentiating between the floating matter and settling matter here. So this is particularly glass rich feedstock. Generally during subjected to screening, glass rich feedstock produced by the screening, the heavy fraction of air classified waste after the separation of the ferrous material. I hope you are getting my point. After the waste is subjected to magnetic separation of the ferrous materials, we get a heavy fraction of glass rich, or that could be some chips or rocks pieces or bricks, some pieces of bones and dense plastic materials will be there, and this flotation technique is used to separate such light particles and heavy particles. So after this, it is submerged in water, okay, in a tank, glass rich feedstock. After screening is immersed in the water, and after removal of the ferrous metal, there may be some other pieces or small chips of heavy materials such as glass chips, rocks, bricks, bones, any dense plastic material. They sink to the bottom as their specific gravity is more than that of water. and are removed with belt scrapers for further processing. And what happens, light organic matter and other materials that are floating on the top, they are skimmed off from the surface. Such kind of a mechanical arrangement is made. And these materials, both light as well as heavy materials, can be taken to landfill site, or if funds are available, depending upon the situation. It's a very, you have to take some decisions depending upon the kind of technique in the itself. So what ultimate objective, funds are available, legal aspects, there are so many aspects as I told in the previous classes. Either you can take these material for landfill operations, okay, or if organic fraction, particularly organic fraction, not inorganic fraction, organic fractions can be taken to incinerators for energy recovery. Thus, dear students, now we have completed all the physical techniques of the processing, that is component separation, mechanical volume reduction, mechanical size reduction, and some other techniques which are used for specific purpose in the component separation. So this completes discussion related to the physical techniques of the waste management. Okay. Then here I would like to show you few videos only. Okay. We have discussed so many techniques, and I have shown you line diagram mainly because in the examination it's not possible for you to draw the photos and all that. So line diagram, as an engineer you should be able to write, then only you will get a full mark. So I have given all the line diagrams, and now you know what is the screening, what is compaction, okay, what is threading technique, various kind of thing, component separation, what is magnetic separation. Like that you will get the videos in the YouTube for all the kind of operation. Suppose in visualizing whatever you study during your study, if there is small confusion to understand that, then just go to YouTube and just look into some of the videos, whatever it may be, and you will get the idea. That is very, very necessary. I request all of you, the time does not permit me to complete all the videos and all that, okay. So I request all of you, whichever videos are available, almost all the videos are available for all the techniques whatever we have discussed. You go through them, and few of them I am showing here. So I, as a teacher, I hereby would like to acknowledge the YouTube for taking the resources from the YouTube for academic purposes. Okay. Okay. Yeah, now I will play the videos. You carefully look into that videos, and then I will just talk few ideas about those YouTubes. Okay. Mainly the YouTubes are, one is related to one screening, trommel kind of a drum kind of a screening, and other videos is a kind of what you say animated incinerator for the, not incinerator, animated of the what is that, sorting technique. Okay, what is that? Sorry, I just forgot what is that technique. The technique is, oh, can you remind me, any one of you? That is optical. So these, and one is general plastic. How dangerous is the plastic? How important is to segregate the plastic at the source, or maybe at any stage of time during the management. We have to very careful about the plastic. So these three are the videos. I once again acknowledge the YouTube for using their resources for academic purpose.
Our oceans sustain life. An abundant ocean can feed 1 billion people a healthy meal every day forever. But now they are being killed by throwaway plastics. The equivalent of one garbage truck of plastic is dumped in the sea every minute. 17.6 billion pounds every year. Plastic is everywhere in our ocean, floating on the surface, mixing in the salt water, and sitting on the ocean bottom, miles and miles deep. And once in the ocean, it never goes away. Over hundreds of years, it breaks down into small pieces. But those pieces, even the tiny ones called microplastics, are still plastic. Sea turtles are choking on it. Scientists say that over 60% of whale and dolphin species are affected by it. Zooplankton, the base of the ocean food chain, eat it. And so do we. It's in the water we drink. It's in our food. Microplastics have been found in our salt, our honey, and our beer. And sometimes even in the air we breathe. Companies are choosing to make something that will be used just once, from a material that lasts forever. If you don't like what throwaway plastics are already doing to our world, brace yourself. We face a tsunami of throwaway plastic in our and the ocean's future. 4 times more plastic will be produced between now and the middle of the century than has been produced in all of history. 4 times more. What can we do? Recycling? Of all the plastic ever generated as of 2015, only 9% was recycled. Even when it is recycled, plastic degrades. Your plastic soda bottle maybe becomes a shampoo bottle, then a floor mat. Even in the best case, it doesn't recycle, it downcycles. And then it becomes pollution that ruins our beaches and chokes sea animals forever. We should not be forced to pollute the ocean every time we eat, drink, or go shopping. We need to be given a choice. A plastic-free choice. This is not hard to imagine. Indeed, some responsible companies are already leading the way. There are throwaway plastic-free aisles in supermarkets. Beverage companies already offer plastic-free soda and salsa water. Restaurants offer plastic-free service. There are plastic-free rooms in hotels. An airline is now offering a plastic-free flight. And Oceania and our allies are winning plastic-free victories. Following campaigning by Oceania, Peru passed a law that keeps plastic out of national parks and beaches. Belize is getting rid of styrofoam. And the European Union has mandated reductions for throwaway plastic throughout its 28 member countries. But with your help, we can do more. Together, we can create a movement to reduce throwaway plastic. We can make sure we're all given real plastic-free choices. We can help our cities, towns, schools, and workplaces establish zones that are free of throwaway plastic. Let's stop plastic pollution from wrecking our beaches and our oceans, and have healthy oceans that delight and sustain us for generations to come. Please join our campaign. Go to oceana.org/plastics today.
Students, I think you have carefully observed the three videos, one related to optical sorting, another one related to trommel, and one related to how dangerous is the plastic and why it is so important to see that plastic is minimized, plastic usage is minimized to protect the environment. And such videos for all the topics need not be only module 2. For all the modules, you will have such videos. You study properly and then look into the videos. Don't directly look into the videos. Try to read them, try to understand and visualize on your own. Then you will enjoy. Then you see what is the difference between what you imagined, how practically happens. Then the subject goes deep into your mind and you will be clear of the subject. So don't think it is a theoretical subject. All the discussions, I hope now you understand, there is some technology, there is some technical aspect behind using the various techniques. And maybe it is brief, but notes, I am going to give you notes which is elaborate, and I am so confident that I have gone through the various question papers, previous questions papers of the VTU question papers. I am so confident that if you use those my notes, elaborate notes regarding the module 2, I think you don't have to even refer any of the books. Okay, of course you have to read the books, but I tell you, I will try to cover almost all the aspects of whatever module 2 I am discussing. And again I repeat, the best book for that is Integrated Solid Waste Management by George Shabana, Mega Health publication. Yeah, this is whatever I discussed so far is regarding the physical processing of the waste. I told there are two other techniques of the processing or transformation of the waste. That is, one is chemical processing or chemical transformation, and other one is biological transformation. So although in the syllabus it is given that volume reduction by incineration, basically it is a chemical processing. What is the difference between chemical processing and physical processing? In the physical process, we never alter the physical properties of the waste. We simply modify the physical properties. Basic chemical nature of the materials, various materials remains the same. Whereas in the chemical processes, there is a phase change. Solid may get converted into gas mostly, or there are some techniques of chemical processing where solid waste is also converted into part of a thick tar like a liquid material. So here change of phase takes place. That is chemical processing. And the definition of the incineration, okay, it's very important. Try to understand, it is a controlled burning of the solid waste at very high temperature, nearly 900 degrees Celsius, in a facility designed for complete and efficient combustion. That means it is nothing but controlled burning of the solid waste at very high temperature in presence of sufficient quantity of air. Okay. Interestingly, you see, the origin volume of the solid waste gets reduced by 85 to 95%. If 100 kg of solid waste is there by weight, hardly 5 kg remains as a ash. This is the greatest advantage of the chemical processes, and another advantage we shall discuss, other advantage also we shall discuss, and mainly the combustible fraction is mainly organic in nature. Okay, so it is nothing but a controlled burning of the solid waste material at very high temperature in a facility designed where sufficient quantity of air is supplied. The major advantage is that significant reduction up to 95% is possible, and which is helpful for the increasing the lifespan of the landfill facilities. Yeah. Many times there is a confusion. That is, what is the difference between incineration and combustion? Interestingly, in the George Shabanagla's book, he has not at all used the word incineration. Okay, he has used the word combustion of the MSW, municipal solid waste. So then what is the difference? Okay, the key difference between the combustion and incineration is the combustion term refers to chemical reaction. Yeah, this is what is important. It is a chemical reaction between the solid particles or substances and oxygen which is present in the air. It is a chemical reaction, stoichiometric chemical reaction, whereas incineration, refers to the destruction of the materials, burning in presence of the air. What kind of chemical reaction? That is the rate of chemical reaction. Generally, we are not bothered. We simply burn it, and combustion is a very specific purpose, organic fraction only. Here in the incineration, we put organic, inorganic, many times all the waste, whatever, collected earlier, they used to dump and burn it in the open land. That is also kind of nothing but an incineration. Whereas the combustion is very specific chemical term reflecting the chemical reaction between the oxygen present in the air supplied and organic fraction of the municipal solid waste. So this is the necessary. Yeah, I told there are many advantages. I hope now try to recollect physical methods parallelly. Okay, there also we discuss volume reduction, mechanical volume reduction by compression process or densification process. And what is the advantage of those processes? You should be always able to compare. Then only as an engineer you will be able to take a call on a particular situation. You should be very clearly what are the relative advantages, disadvantages, one thing, what is the economy between the two, what is the environmental aspect, legal aspect. So here also we are achieving volume reduction. So one of the major advantages of the incineration process is that a significant volume reduction, efficient incinerations. Okay, if the incinerations are properly managed, okay, then the combustible fraction of the municipal solid waste reduced by 85 to 90%, even 95%. Okay, and thus hardly 5 to 10% remains, depending upon the, of course, this percentage of removal depending upon the composition of the solid waste. Okay, and it can be parallelly. What happens here, we get reduced, obviously the volume required for landfill also gets reduced. Or if already you have decided the volume of the landfill site, then you can increase the life of the landfill site, because daily you are only putting 10% of the solid. If you are putting everything, the solid waste or that landfill site gets filled up, and again you have to go for some other site. And remember, there is only one earth. Okay, all the water resources, land, everything is finite and limited. We have to make optimum use of the land. ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು, ಹಳ್ಳಿಯಲ್ಲಿ ಆ ಕಡೆ ಎಲ್ಲ ಕಡೆ ಈಗ ಎಲ್ಲರದ್ದು ದುಡ್ಡಿದೆ ಆದ್ರೆ ಲ್ಯಾಂಡ್ ಇಲ್ಲ. ಅದಕ್ಕೆ ಲ್ಯಾಂಡ್ ಫಿಲ್ ಡಿಸ್ಪೋಸಲ್ ಮಾಡಬೇಕಾತಂದ್ರೆ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ದ್ಯಾಟ್ ಎಷ್ಟು ಕಡಿಮೆ ಆಗುತ್ತೋ ಅಷ್ಟು ಪ್ರೊಸೆಸ್ ಮಾಡಿಬಿಟ್ಟು ಎಷ್ಟು ಕಡಿಮೆ ಆಗುತ್ತೋ ಅಷ್ಟನ್ನು ಮಾತ್ರ ಸಾರಿ ಲ್ಯಾಂಡ್ ಫಿಲ್ ಸೈಟಿಗೆ ಒಯ್ಯಬೇಕು. ಸೊ ದಟ್ ಗಾನ್ ಆರ್ ದ ಡೇಸ್ ಅರ್ಲಿಯರ್ ಆಯಿತು ಎಲ್ಲಾದ್ರೂ ಒಯ್ದು ಡಂಪ್ ಮಾಡಿಬಿಟ್ರೆ ಆಯಿತು ಅಂತ. ಈಗ ಹಂಗಿಲ್ಲ, ಲ್ಯಾಂಡೇ ಸಿಗಲ್ಲ ಅಲ್ಲಿ. ಇಮ್ಯಾಜಿನ್ ಎ ಸಿಚುವೇಶನ್ಸ್ ಆಫ್ ಎ ಬೆಂಗಳೂರು ಸಿಟಿ, ಇಟ್ ಇಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ಗೆಟ್ ಎ site for a landfill. So thus in this context, the volume reduction almost up to on an average 85 to 90 we can say. If very efficient, even it may be up to 95%, significant reduction in the volume of the solid waste. Waste stabilization, yeah. Yes. the waste which is subject to incineration process, particularly organic fraction of the municipal solid waste, gets converted into a product, solid product, which is ash, and remember that is chemically inert. So when such a solid waste is taken to the landfill site, okay, as it is inert in nature, of course, if I say this is a cross section of the landfill site, of course, of the late these days we are using lined impermeable member inside that pit or whatever you say for use for a landfill site. When this is filled, okay, with a ash, as that is inert in nature, there is no chance of a formation of a leachate. Okay, I hope you know what is leachate. When solid waste is dumped and rainwater falls on that, the water percolates to the hump or heap of a solid waste, and many of the materials get dissolved into that liquid, which is very, very, very toxic in nature when the commingled waste is used. And imagine a situation that leachate, if percolates through the bottom, if it is not lined, which will lead to the groundwater pollution. Already the water is also very scarce commodity in a present day scenario. So groundwater pollution is to be avoided. So as it is inert, even if by chance leachate forms, okay, it reduces, even if by chance it forms, no, it is not going to harm anything. And gas after disposal. So waste stabilization, the solid waste gets converted, in simple words I would like to say, the solid waste gets converted into a inert ash which is environmentally friendly, right? This is one advantage. Next, during the incineration process, we can generate energy, okay? The hot steam, okay, gets converted into electrical energy or electricity, which can be used for local factories, or some industries are using incinerators. It can be used for in-house operations. Like that, the another advantage is that significant production of the energy. Energy can be recovered because burning heat energy can be converted into electrical energy, which can be exported to the local factories. This is another. And third one is waste sterilization. Try to understand the difference between stabilization and sterilization. It is quite possible that municipal solid waste, okay, we shall, we shall continue in the next class the waste sterilization and other advantages of the municipal solid waste. Thank you.